the yellow sheet of paper I handed out, solving multivariable equations. This is how you do these problems. I have included every scenario that could possibly happen with this procedure here. Which means if you don't have parentheses, skip that step. If you don't have fractions, skip that step. If you don't have, or you're usually going to have multiple variables, so you're going to have to do steps 3, 4, and 5 happen almost every time. But steps 1 and 2 for right now, I don't think are going to happen yet. I don't remember any parentheses or fractions happening in the problem we're going to see today. So basically we're going to be doing steps 3, 4, and 5, but again, as we revisit this topic, they're going to throw parentheses in, they're going to throw fractions in. We'll have to deal with those when we get to them. Example 1 says solve for y.
Don't forget to record.
I'm already hit record, thank you. Remind me though. Alright, so example 42.1. Solve for y, 6y minus x plus z equals 4. Now let me go back here real quick, and I'm just going to put a little star right here next to 3. That step is where you care what you're solving for. Okay? If there's parentheses, I don't care what I'm solving for. If there's fractions, I don't care what I'm solving for. Deal with those two issues first before you worry about that. Once you get to step 3, what am I solving for is going to be important. All right? And again, for today, 3, 4, and 5 are the only steps we're going to have, so we're immediately going to need to know what we're solving for. All right? And when I say variable of interest, that's what I mean we're solving for. So if it says solve for y, y is a variable of interest. It says solve for x, that's a variable of interest, and so on. So, solve for y are my directions, and again, since there's no fractions or parentheses, I am immediately on that. Step 3 tells me to rearrange things so my variable of interest is on one side, everything else is on the other side. It doesn't matter which side's which. So, looking at my equation that I have, 6y minus x plus z equals 4, which terms contain the letter I care about?
6y.
6y, and that's it, right? Everything else doesn't. Okay? So again, step 3 is all about separating things out. I got an equal sign, I put stuff on one side, stuff on the other side. I want this all by itself, and I want everything else on the same side, but opposite from 6y. Alright, so 2 ways to make that happen. Way number 1, I can move the 4 to the left, I can move the 6y to the right. That would make that happen, right?
Yeah.
Everything on the left would be red, everything on the right would be blue. All would be fine, right? Option number 2 would be to move x and z over to the right, keeping 6y and 4 where they're at. That would keep everything red over to the right, everything blue over to the left. Both of those options are correct. It doesn't matter which one you choose. Okay, I'm going to do it both ways, I think. Oh, this is okay, different. So I'll do it both ways here. Used to be where I had the same problem twice, we did it both ways, but I'll just do it both ways here. I'm going to put a line down the middle here. Alright, so for this one I'm going to go ahead, since I already got the arrows drawn, I'm going to keep the 6y where it's at. 6y is staying, so it stays positive. The equal sign is going to move closer to 6y just to give me some room over here. The 4 is staying where it's at, it's staying positive. X is moving across, it becomes plus x. Z is moving across, becomes minus z. Okay, so 6y equals 4 plus x minus z. That's what step 3 is all about. If you do step 3 correctly, you should have an equal sign separating things that have the letter you care about and things that don't have the letter you care about. Then you simply divide by whatever's in front of that.
Do you reduce?
If possible, you reduce, and let me just go back here real quick. Notice there's in step 4 combine like terms. There weren't any, so we skipped that, right? So I went straight to the division step, step 5. Amber's question about reduction. Can I reduce that fraction is the question you ask yourself. Now here's how you decide whether or not you can reduce a fraction. It's real simple. It kind of goes back to what I just mentioned at the beginning of class with that 25x squared minus 5x. It's not in the video, but I've got a sum or difference over a number, right? So I've got multiple things. Is there a common factor?
Yeah, no.
No. Nothing evenly divides 4x and z, right? So there's no common factor, so it can't be reduced. Another way of considering reduction possibilities is this. It's real simple. Look at every single term individually. All right, look at all 4 of those terms, 4x, z, and 6. Does anything evenly divide all 4 of those numbers?
No.
No, so it doesn't reduce. The 4 and the 6 would reduce, but the x and the z are attached to the 4, so you're not allowed to reduce pieces of things. So that's the correct answer, y equals that thing. All right? Now, the reason I'm going to go the other route is this. Sometimes we do an odd number problem, we get our work done, we check in the back of the book to verify that our answer is correct, right? And we go in the back of the book, and this is the problem. In the back of the book, they have this answer. Y equals x plus z minus 4 over negative 6. That's the back of the book answer. And that's what we got, that's what the back of the book says the answer is. And all of a sudden we start thinking, I must be wrong because the back of the book's never wrong. They're really smart. Right? Back of the book's smart. Back of the book's wrong sometimes too. Anyway, they're right this time, but we're right also. So here's the thing. I want to show you why we're right and how you can tell you're right so that you don't do a problem like this, get that answer, see this answer, and all of a sudden think I must be wrong. You know what? Now it's right. Sorry. That's what the back of the book says the answer is. Alright, so if I did that other movement, so if I move the 6y over here and the 4 over there, let's see what happens. So I'm going to get negative x plus z minus 4 equals negative 6y, right? So the x stayed where it was, stayed negative. Z stayed where it was, stayed negative on the left-hand side. The 4 moved across, becomes negative. The 6y moved across, becomes negative. Then we divide everything by negative 6 because, again, there's no like terms. And that gets me this answer that I just showed you, negative x plus z minus 4 over negative 6. Both those techniques are exactly right. Both answers are exactly right. Here's how you can compare answers without having to rework the whole problem, because I don't want you to have to rework the whole problem. That's kind of ridiculous to have to do the same problem twice just to verify you got the same answer in the back of the book. What's on top here? Just worry about the numbers, don't worry about signs.
4x.
4x and z, right? On top, 4x and z. Same things on top, on the bottom, 6 on the bottom, 6. Everything's the same on top, everything's the same on bottom. The other thing that has to happen for them to be the same answer is every single sign has to be opposite. Every sign's opposite. So positive 4, negative 4. Positive x, negative x. Negative z, positive 6, negative 6. Every sign's opposite. Everything's in the same location. Order's not necessarily the same. That doesn't matter. But the same place top, same place bottom. Opposite sign on every term, they're the same answer. All right, so if you're a back of the book checker, just know that sometimes the back of the book goes the other direction. Just know that if you got the right answer, you can compare them still without having to rework the whole problem. That'd be what I want from you. If you're going to the back of the book and just writing the answer out of the back of the book without doing the problem on your own, it'll catch up to you on a test. You don't know how to do anything and you'll miss those test questions. So don't do that. That's a bad thing.